What would it mean if a single child, thousands of years ago, opened their eyes beneath the dim sky of the Ice Age, with hair as pale as midwinter frost, skin untouched by pigment, and eyes that shimmered like the surface of a frozen lake? What would their presence say about the hidden variations that once lived among Neanderthals? Variations we cannot see in bones, cannot trace in tools, cannot capture in cave walls? And what if the answer is not simply about one child, but about how unpredictable human genetics once was? How many paths ancient populations could have taken, and how many forms our relatives might have worn as they walked across the mammoth plains? This is a story without fossils, a question without a carved symbol or a piece of hair preserved in ice. Yet it lingers, quietly, between what we know and what might still be possible. Neanderthals were not a distant species of beasts. They were a branch of humanity, a people shaped by relentless winters, small family bands, and a level of genetic isolation that modern societies can hardly imagine. Their genomes, recovered from tiny fragments of bone, already reveal a surprising spectrum of pigmentation. Individuals who may have been deep-toned, others lighter, all shifting across generations. As clans wandered through valleys, crossed ice-choked passes, and adapted to landscapes that offered little mercy. And so, a deeper question drifts to the surface. In groups so small, so widely scattered across the Ice Age world, could rare genetic conditions have appeared more often than they do today? Could a single mutation, one spark in the code of a single child, have quietly spread through a community, simply because there were so few individuals? To dilute it, this idea is not born from fantasy. It comes from the mathematics of inheritance, from what happens when generations unfold, in populations that number in the dozens, not the tens of thousands. It comes from understanding how fragile ancient humanity truly was, how close to the edge they lived, and how easily a small shift in genetics could ripple across an entire lineage. Pigmentation is a spectrum, a shifting gradient, rather than a fixed identity. It rises from melanin, from how much the body produces, how it moves through the skin and hair, and how those pigments interact with the light that reaches the earth. During the Ice Age, that light was scarce. Sunlight arrived, filtered through heavy cloud cover, muted by long winters, and softened by the high latitudes, where early humans made their home. Snowfields amplified brightness, yet offered little true warmth, casting a cold, blue-white glow across entire continents. In this dim and reflective world, both Neanderthals and early Homo sapiens faced the same biological pressures. Evidence suggests that, over many generations, their pigmentation gradually lightened, a subtle but steady response to environments where UV radiation was too weak to support darker tones. This evolutionary shift did not happen quickly. It was shaped by countless lifetimes of adapting to clouded skies, limited sunlight, and landscapes that forced the body to work harder for every trace of vitamin D. Against this backdrop, the idea of even more extreme reductions in pigment becomes scientifically reasonable. Not a conclusion, not a claim, but a biological possibility, rooted in the same forces that shaped the appearance of Ice Age humans themselves. Among the more intriguing discoveries to emerge from Neanderthal genetic studies is a distinctive version of the MC1R gene, a gene central to the orchestration of pigmentation. This ancient variant does not appear in any modern human population, suggesting that Neanderthals carried a unique molecular signature within the pathways that govern their skin and hair. Researchers believe this mutation may have contributed to lighter hair tones. In some individuals, a subtle brightening that would have stood out against the blue-gray backdrop of Ice Age Europe. And while this finding does not directly indicate albinism, it does remind us of something essential. Neanderthal pigmentation genetics were not a simple reflection of our own. Their bodies followed rules, that diverged in small, intriguing ways. Rules shaped by isolation, climate, and tens of thousands of years, spent evolving apart from Homo sapiens. The discovery of one unusual pigmentation mutation invites a deeper question. If such a variant existed only in them, unknown to modern genomes, what else might have emerged in those small, scattered groups? What rare or delicate shifts in coloration might have flickered briefly through a family line, leaving no visible trace? On the fossil record we depend on today, in the silence of deep time, these genetic surprises remind us that Neanderthals were not static or uniform. They were a population full of hidden variations, many of which we may never fully uncover. Albinism, as we understand it today, is not a single condition. It is a broad family of genetic variations that influence the body's ability to produce or distribute melanin, the pigment responsible for the shades of human skin, hair, and eyes. When melanin production is reduced or disrupted, the results can be striking. Skin that appears almost translucent, hair so pale it seems dusted with snow, eyes with hues that shift subtly under different kinds of light. Yet each form of albinism follows its own genetic pathway. Some variations affect only pigmentation. Others influence how the eyes develop, how light is processed, or how sensitive an individual may be to bright, reflective environments. In a prehistoric world, the expression of these conditions would have been shaped by a tapestry of environmental pressures: the dim winters of high latitudes, the sharp glare rising from snowy ground, the demands of foraging and hunting, and the rhythms of small, closely knit communities. To consider albinism in ancient humans is not an attempt to apply modern labels to people who lived long before such words existed. It is instead an exploration of possibility, a question of whether the same genetic mechanisms that produce these variations today could have quietly existed in our archaic relatives as well. When viewed through this lens, albinism becomes not a claim about the past, but a window into the complexity of human biology across deep time. Small, isolated populations create conditions where rare traits can take root more easily than we might expect. When a community numbers only a few dozen individuals, a single genetic mutation can move through the group quietly, not because it offers any advantage, but simply because there are so few people to dilute its presence. Neanderthals lived in exactly such circumstances. Their world was divided into scattered family bands, stretching across vast Ice Age landscapes, separated by mountain ridges, deep river valleys, and long periods of seasonal hardship. Contact between groups could be infrequent, leaving each community to drift genetically on its own. In environments like these, the unusual does not always disappear. A rare trait can linger, carried from parent to child, woven into the fabric of a lineage, for reasons that have nothing to do with fitness and everything to do with chance. This framework does not prove that albinism existed among archaic humans, but it anchors the idea in the realities of ancient population genetics. It shifts the question away from speculation and places it firmly within the patterns that small human groups naturally produce. Patterns shaped by isolation, by time, and by the unpredictable math of inheritance. To understand what a trait like extremely low melanin might have meant in the deep past, we have to step fully into the Ice Age itself. Winters stretched for months. Days arrived wrapped in muted gray. Forests stood motionless beneath heavy crowns of ice, their branches bending under the weight of a world locked in cold. Snow covered nearly everything, scattering what little sunlight existed into a diffuse, blue-white haze. It illuminated the land, without truly warming it. This was the backdrop against which early humans lived their entire lives. In such a world, pigmentation mattered. Lighter skin helped the body absorb scarce UV radiation, a quiet advantage in places where sunlight was weak but essential Darker skin offered resilience. When brighter seasons finally returned, shielding against glare, and the rare but intense bursts of summer light. For an individual with extremely low melanin, if one ever walked these frozen plains, life would have been shaped by a delicate balance of hardship and refuge. Snowfields might have overwhelmed the eyes, forcing them to turn away from the shimmering landscape. But caves, dense conifer forests, and the long twilight of winter would have softened these challenges, wrapping the world in gentler tones. Neanderthal life unfolded in places where light was fleeting, where visibility shifted with the seasons, and where survival depended less on appearance and more on cooperation, on shared food, shared shelter, and the unspoken bonds that held small communities together. Imagine a stone shelter, resting at the edge of a frozen spruce forest, its entrance half draped in snow that glows faintly under the shifting firelight inside. The flames pulse and bend, casting long, trembling shadows across the rough floor. Stone tools lie scattered near drying hides, their edges catching brief flashes of orange. As the embers rise and fall, a small Neanderthal group huddles together, broad shoulders wrapped in thick pelts, faces carved by cold winds, and the long memory of countless winters. Their breath drifts through the air, in soft, clouded ribbons. Near the back of the shelter, a young child crouches over a carved bone, slowly turning it in their hands, as if studying the story hidden inside. When the firelight reaches them, it reveals something striking. Skin touched by a pale softness, almost translucent in the glow, as though it reflects light, rather than absorbing it. Hair catches the warmth of the flames, in strands so light, they seem woven from frost. Eyes shimmer with a subtle, icy brightness. Unfamiliar, unexpected, yet undeniably human. No one stares. No one recoils. Within small communities built on shared effort, difference is simply folded into the fabric of daily life. A natural variation, a quiet thread in the weave of the group. Wind sighs against the cave mouth, slipping past stone and hide, like a messenger from an older world. And for a moment, the scene feels suspended. A glimpse not of confirmed history, but of a genetic possibility that would leave no trace in the archaeological record we depend on today. Neanderthals cared for one another in ways that archaeology continues to uncover. Bones show fractures that fully healed, indicating weeks, sometimes months, of protection and shared labor. Individuals with long-term disabilities survived far beyond what a harsh Ice Age world should have allowed, which means others gathered food for them, kept them warm, and made room for them within daily routines. Such evidence paints a portrait of communities held together by cooperation rather than competition. In groups this closely bound, an individual with an unusual appearance would not simply be cast aside. Their presence might invite adjustment, a shift in tasks, a different role during a hunt or migration, but their belonging would be shaped more by kinship than by the way they looked. Within these family-sized bands, difference was woven quietly into the rhythm of shared survival. A child who looked unlike the others might become part of the group's stories, its nightly teachings, its sense of identity. Variation has always been one of the ways human communities understand themselves, through the traits they notice, the individuals they protect, and the unspoken bonds that define who is considered one of us. In this light, unusual pigmentation in a Neanderthal child would not mark an outsider. It would simply become another thread in the tapestry of a small, resilient world. Pigmentation leaves no imprint on bone. The soft tissues that carry color, skin, hair, the delicate structures of the eye, are the first to vanish as time takes its toll. What survives the long journey through millennia are the hard materials, tools chipped from stone, teeth anchored in ancient jaws, and the sturdy architecture of skulls. These artifacts speak clearly about strength, diet, and adaptation, yet they remain almost silent on the subtle shades that once defined a face. Even DNA, when we are fortunate enough to find it, comes to us in fragments, small strands that offer hints and suggestions, rather than complete portraits. They tell us something about genes, something about variation, but rarely enough to reconstruct the full spectrum of appearance. If an albino Neanderthal ever lived, their presence would be nearly invisible. In the archaeological record, their bones would look no different from those of their kin. Their tools would reveal nothing unusual. No mark, no pattern, no signature that could distinguish them from the rest of their community. The silence of the evidence is not a contradiction of possibility. It is simply the natural consequence of how little prehistory allows us to keep. Time preserves what is hard and durable, not the fleeting details of color and light that once made each individual unique. To follow this question is to step quietly into the deeper reaches of human variation, a place where our certainty begins to soften and where possibility becomes richer than conclusion. It reminds us that ancient humanity was never a single shape, never a single story. It moved and shifted like light across a frozen landscape, revealing new forms. As climates changed, as families migrated, and as chance carved its own signature into the human lineage, the idea of an albino Neanderthal does not make prehistory strange or unreal. It makes it more intimate, because it acknowledges that our ancient relatives were shaped by the same unpredictable forces that shape us today. Genetics, environment, community, and the quiet randomness woven into every generation. Here on Prehistoric Shadows, we look into these dim corridors of time with patience and respect, guided by science, steady in curiosity, listening for echoes of lives that left behind only fragments, yet still speak through the questions they inspire. If this journey opened even a small window into the complexity of our deep past, then know this: there are countless other mysteries waiting in the dark edges of human history, silent, patient, ready to reshape how we understand ourselves. And here is the truth to carry with you. Even in the coldest ages of the world, human variation found a way to endure.